Nice to see a house full. I just want to clarify one thing. This is a session on methanol, not ethanol. I hope you guys are in the right hall. Right hall? Okay. So just give us 2 minutes. We have the dignitaries, they're just coming down on the way, and we'll start the program. Okay, let's start. Which is a little boring, but then we will get on with it. So we have a little speech from our chairman who is in America. He's enjoying his holidays and he's jotted down a few things which I need to relate to you. So this is from David Birwadkar, our chairman, IMEI Mumbai branch. So it is with immense pleasure that I welcome you all to the crucial methanol training session organized in collaboration with the esteemed METHANOL Institute. Today marks a significant step in our collective journey towards understanding and embracing the transformative potential of methanol as a marine fuel. The global maritime industry is at a pivotal juncture, grappling with the urgent need to decarbonize and adopt sustainable practices. Methanol, with its promising environmental profile and growing availability, has emerged as a compelling solution. We are incredibly fortunate to have with us our esteemed chief guest, Mr. Ajithkumar Sukumaran, Chief Surveyor with DG Shipping. This presence underscores the importance of this event and the collaborative effort required between the industry stakeholders and the regulatory bodies to ensure the safe and efficient adoption of methanol as a marine fuel. Mr. Sukumaran's insights and guidance will be invaluable, and as we delve into the technical, operational and regulatory aspects of methanol handling and utilization, we are also grateful to the METHANOL Institute for the expertise and for partnering with us to bring this vital training session to fruition. This seminar will provide a platform for in-depth discussions, knowledge sharing and practical insights into the latest advancements in methanol technology, safety protocols and best practices. We will explore the challenges and opportunities associated with its implementation and discuss the pathways to a sustainable and cleaner maritime future. The Institute of Marine Engineers India Mumbai branch is committed to fostering a culture of continuous learning and professional development within the maritime community. We believe that by equipping our members with the necessary knowledge and skills, we can contribute significantly to the safe and efficient transition towards a more sustainable maritime industry. I encourage all of you to actively participate in the discussions, ask questions and engage with our expert speakers. Let us work together to harness the potential of methanol and pave the way for a greener and more sustainable future for the maritime sector. Thank you once again for the presence, and I wish you a productive and insightful seminar. So that was from our chair. I will request Neeta and Shobit sir to do the honors of giving the bouquets to our guests. Our chief guest, Mr. Ajithkumar Sukumaran, marine engineer turned maritime administrator, currently serving as a Chief Surveyor with the Govt of India. He's done his BTech Mechanical, Kerala University Operations and Management, IIT Kharagpur. 10 years as marine engineer and over 22 years in DG shipping. He's got a lot of other professional. Let me read it out to you. Member, Academic Council, IMU, Chairman, TED 19, Sectional Committee, Bureau of Indian Standards, BIS also. Represented India in various international maritime conventions at IMO. Leader of Indian delegation to MEPC and MSC, and served as government nominee in the Board of Trustees, Chennai, Cochin and New Mangalore Port Trust. Recently we concluded a green shipping conclave and he was a chairman, and it was applauded by everyone internationally all over the world. That was his brainchild. It was very well executed in the month of February. Can I request Alexander Dahl to please be seated? Alexander Dahl was appointed Chief Operating Officer at the METHANOL Institute in May 2024. He is based in MEI's Brussels office, working with the MEI policy team, and is responsible for supporting MEI members globally. Alex has extensive experience in chemicals industry, including positions at Dow and OCI Global, where he served as Vice Chair of the METHANOL Institute's Policy Committee. A proven leader, Alexander has played a pivotal role in significant initiatives at meetings of COP and the World Economic Forum, demonstrating his ability to address global challenges. Thank you, Alex. Kel Abo, Senior Advisor, Europe. Kel works as a Senior Advisor to the METHANOL Institute. Following a distinguished 40-year career with Man Energy Solutions as a retained consultant, Kel works in MEI in several critical areas to advance methanol as a clean fuel. Welcome, Kel. Program, that's Prakriti Sethi, Chief Representative India from Delhi. I don't know what to read, what not to read. Okay, I'm going to choose now Prakriti. So Prakriti Sethi is MEI's consultant and rep based in India. Her inclusion to the MEI team is part of MEI's efforts to bolster its government relations, efforts and network in key markets around the world. Prakriti has a wide area of experience working with international and national government institutions such as UNESCO. There are these German words. I'll say JIS and the Govt of India. She supported the UNESCO Secretariat as a part of the delegation at the UNEF COP22 and assisted in preparing the UNESCO Small Island Developing State Plan 2016 to 2021. Okay, so she is based in Delhi, and Prakriti can effectively identify and engage stakeholders in government and private sector who will key in furthering India's aspirations to establish a methanol economy. So we have the team here, and I would like Alexander, no, sorry. Wait. So can we request the chief guest to please say a few words?
Good morning to you all. In fact, this is a homecoming for me. I'm a proud seafarer as well as a proud marine engineer, member of this prestigious organization. And more than my official capacity, I would like to be part of this group as a member and as a family member. Thank you very much for inviting me here. I can see a lot of big stars from METHANOL Institute as well as from IMEI. Many of my faces are very familiar to me. But for those who are coming abroad, who are not much aware of the Indian context, let me say that I come from a small southern state of Kerala, out of the 28 states in India. And this is a coastal state, and out of that there is one small island called Vipin. That Vipin island rose to famous or infamous scenarios in 80s perhaps due to all wrong reasons. It was connected with an illicit alcohol poisoning event, which unfortunately resulted in the death of around 77 people. 66 were permanently blinded, and more than 100 were permanently disabled due to various reasons. And in a small island, which is a fisherman community island, of the 1,000 families, around 600 were almost shattered. And the villain behind this was the methanol poisoning. So that is perhaps one of the first instance I could have come across in my school days, the word called the methanol, something like a villainous figure. You may wonder how it is connected with shipping. I just want to mention that an otherwise highly useful product, how it can become a lethal and catastrophic, is not handled safely and purposefully. And from there, if you are talking about this kind of incident, it is not something only happened in Kerala or something like that. No. In 1980s, it has been several instances of that. 100, 200 people died in Gujarat. It has been a very normal occurrence in Orissa or even Tamil Nadu, in many other places. And it is not that it has happened only in India. It has happened in Brazil, even it has happened in places like Australia. And it is not that it has only happened in the 80s or something like that. As late as 2024 November, in a village called the Kalikurichi in Tamil Nadu, 60 people just died because of methanol poisoning. So how it has happened is a different scenario. But what I want to say is that there is any product, anything which is useful to the community needs to be safely and purposefully utilized. That is what the relevance of this kind of forum and this kind of meeting, where we enrich ourselves when we are facing an evolving scenario. So when it comes to the ship, incidentally, my first ship as a chief engineer was a dedicated methanol carrier. Here again, I faced one of very unfortunate incident in which one of our chief officer and one of our cadets, they were taking a sampling through the sampling port. I don't know exactly what happened. Both of them collapsed. And it was only fortunate that we were in a European anchorage so that they could be airlifted immediately and could save the life. But of course, it has got its own challenges. And the challenges are more, we have been carrying the methanol as a cargo for years together, and we are very used to such kind of scenario, both in the chemical industry as well as in transportation industry like shipping. But now we are facing a new scenario, methanol as a fuel. If you see methanol as a fuel, again, it has been in useful purpose in many sectors. For example, if you are seeing one of the famous sector is what you call for the methanol use as a fuel is the racing cars, because of its high octane number and the conversion ratio. It gives more power, and so it is widely used in some sectors of methanol, in racing car operations. But just see, one of the widely circulated video in recent times has been a fire involved with that. That is Indianapolis of 1982 fire incident in which the Keith, many of might be who are interested in racing cars must be knowing about it. The kind of the situation, it is simply scary if you see the video, because the fire is quite invisible. So around the people doesn't know what exactly is happening. So see, you can fight somebody and fight an enemy provided you see him, you are aware of him. But how can you fight something which is invisible? So that is the challenge here. But at the same time, it has got some reality places before us. Whether we have some kind of choice. Knowing the developments in maritime sector for the decarbonization efforts, I must say that it is at least very, very limited, the options. Because the way in which the IMO discussions are going on, how it is, maybe in 83 or 84 they will finalize the economic measures. So I think it is something which we cannot say no. What happens is that even like IMO and other organizations, so I have been involved with IMO regulatory framework for quite some time. But the things, the way in which it is moving is something unprecedented. Because the committee is like a Marine Environmental Protection Committee, which ultimately makes the technical regulatory framework for the shipping industry altogether. One of the primary sector was decarbonization. Overall, as you know, many of you, I hope, are connected with the seafaring. So must be knowing the kind of technical and operational measures which have been in place for the decarbonization efforts in the maritime sector. But IMEPC, predominantly a technical driven organization, is today not limited to that. They are venturing into the sensitive areas which perhaps people like us is much worried where it will head. So it is going into the commercial aspect of the shipping industry. The regulatory framework getting into the technical, the technical as well as commercial industry is a very dangerous combination, because we don't have much choice. So, and the people will be driven by the commercial aspect of that than the technical aspect of that, the technical feasibility. More than that, they give priority to the financial sustainability, which eventually results in solutions which are for a commercial industry like shipping, which is sustainable or economically viable. That is why I said the scope or the reason means the choices before us very limited. But at the same time, honestly speaking, the challenges when the IMO committees like IMEPC is rather getting into policy decisions or in that protection the political decisions. So whether they are concerned about the challenges involved on the ship and ship operators, particularly the seafarers, with honest admission, I say that perhaps not to the extent which traditionally be the pattern of the organization like IMO. Because they are focused more on how the decarbonization to take place and the solutions toward that. They hardly today speak about the challenges involved going to be for that ship operator or the seafarers they are going to face on a ship. So for example, I used to wonder, sarcastically or I used to mention that today what we need or seeing the way in which the fancy fuels are coming up, the kind of people we need for the ship operation are not marine engineers, but chemical engineers. Because the kind of the fuel and it is something like going to be something like a chemical factory. So what is going to be the scenario? Nobody knows. But this is the time when organizations like Institute of Marine Engineers and professional bodies like METHANOL Institute to come together to have a safer industry before us. To give a safety perspective to that, a purposeful perspective to that, and how we can work together so that our seafarers, our the industry is well equipped to an eventually unavoidable scenario which is much earlier than we all expect. So that is for that perspective. Let me thank wholeheartedly the Methanol Institute for giving such kind of insightful sessions, and of course I must thank the Institute of Marine Engineers for organizing this kind of programs. But finally, let me also say that it is more than decarbonization. There is something called the economic aspect to that also. So I think the Methanol Institute must be much aware of the methanol economy program by our Niti Aayog of the Govt of India. If you go by their predictions, the methanol industry itself is going to create around 4 to 5 million job opportunities in the coming decade for India alone, both for the production, transportation, as well as for the operational utilization. But not only that, they said that, see, as you all know, that India is a highly fossil fuel importing country with around 230 million tons imported last year in 2024, which amounts to somewhere around 130 billion bill for our import of oil. But around the 15% of mixing of methanol with gasoline can reduce the import cost by around 15 billions, if you can just calculate. So that is the economic way in which the government, I mean the government or the methanol sector is seeing as a fuel itself. Even other the simple, if you are diluting around 10 to 15% in LPG gas, which is being used by the home use, it would simply save around 6,000 crores per annum. So this is what the figures which will come from the methanol economy. So it, more than that, a decarbonization has got an economic angle also. So in both ways, I think this is something which we cannot afford to neglect. So when we see that some scenario is something unavoidable, it is better to get prepared for that. So all the best for the participants of this seminar. I hope this will be very fruitful. And thank you once again for the Institute and as well as information.
Thank you, Ajit sir. Thank you very much. We did forget one part in our program, that's the briefing, the fire safety. So, Mohan sir, can I just...
Good morning, Chief Surveyor, to Govt of India and dignitaries on the dais, as well as good morning to ladies and gentlemen in the audience. Let me give you the safety familiarization of this. This is our premise. In case of fire, action to be taken in the event of fire alarm sounding. Today we don't have any drill or any basically exercise for carrying out fire. So any fire alarm sounds, it is genuine alarm. In case of fire alarm sounding, please evacuate this hall. You have a exit from this hall at the back where you are sitting, then you are on the left as well as on the right. These are the 4 exits which are clearly marked out there. Then this is the assembly point where in case of fire everybody is expected to assemble. So where we can very much account for everybody. This is at the next to the entrance, generally exit. In this is what the 2 exit at the back. This is the another on the left side. This is on the right side of all of you who are sitting out there. In case of your any eventualities, we have to basically assemble at this point. This is the exit gate. This is most of us have entered in this gate. This is the entry gate. First aid has been already indicated that this is located at the staircase next to the elevator. In case it is required, in case of any serious matter, we have tie up with the Apollo Hospital nearby. So please do let us know in case of any of you have any issue, serious issue, medical serious issue. Then this room is covered by CCTV. Okay, so be careful whatever you action doing. If you are dosing during the seminar, be careful.
Right, thank you, Mohan sir. Please come for his words of wisdom.
Good morning. Chief Guest, Chief Surveyor Shri Ajithkumar Sukumaran, thank you for your leadership. Thank you for your inspiring words this morning. Thank you to the Institute of Marine Engineers in India and distinguished guests and colleagues. It's a real pleasure to be with you here today in Mumbai, a city that has long stood at the crossroads of global trade and today stands at the heart of maritime innovation and ambition. This event's focus is not only timely, it is essential. The global shipping sector is under growing pressure to decarbonize, as you all know. We face international mandates, investor scrutiny, and public expectations that all point into one direction: cleaner, more sustainable maritime operations. It's very clear. And among the many solutions being explored, methanol stands out. It offers one of the cleanest, clearest, most practical, most scalable pathways available right now. We're no longer talking about pilot concepts. Methanol-powered ships are being built and launched. Ports are bunkering or preparing for bunkering. Supply chains are adapting. The transition in maritime is no longer in theory, it's a movement in motion. But let me be direct. What holds us back is not the technology. It's not about whether dual fuel engines or fuel tanks work, because they do. What slows us down is instability, uncertainty and regulation, fragmented international standards, and the absence of consistent long-term infrastructure and investment strategies. These are the real bottlenecks, and they demand leadership to overcome. And I have to say, India is actually showing that leadership right now. From an infrastructure perspective, the Sagarmala program with over 800 projects is transforming coastal connectivity and port modernization at a huge scale. That alone positions India to serve not only its own shipping needs, but to be a central player in regional and also global maritime logistics. And meanwhile, ports like Kandla are emerging as strategic deep water hubs, capable of handling the largest ships in the world and located just off key global shipping routes. At the Chidambarar, India is moving towards establishing its first green methanol bunkering facility. A clear signal that the country is not just watching the marine fuel transition, but it's also helping to shape it. India's vision is clear, and crucially, it's being backed by action, and that is exactly what we need. And the vision is powered by talent. Indian marine engineers, surveyors, maritime professionals, they are widely respected across the global industry. Not just for their technical skills, but for their professionalism, their precision, and their ability to lead in complex, high-stake environments. That reputation matters, and it reflects generations of excellence. So where do we go from here? We must seize the moment. We must align across the entire value chain. From fuel producers to ship owners, from port authorities to regulators, from finances to technology providers, to bring methanol into the mainstream of marine fuels. This is not a niche opportunity, it's a defining one. India is not just a participant in the maritime industry transition. India is positioned by geography, by policy, and capability to be a key architect of it. thank you for that. Now, before closing, I just want to say one thing. I just received these beautiful flowers, and they're not just beautiful, they're actually close to my heart. And you know a little bit about me. I'm from a very small village close to Amsterdam. It's called Aalsmeer. All the flowers that are grown for the export are being auctioned in that little town, in that tiny country called the Netherlands. Every day, millions of flowers are being auctioned there. Also, all the bulbs that are being produced in the world, they go to that small village to being auctioned and sent out again. But flowers actually saved the Netherlands during the war with the Germans, World War I and World War II. And I give you a hint, so when you come to the Netherlands, no one will find out that you're not from the Netherlands. I'll show you a very simple trick. So, these beautiful flowers, they saved our country. And the reason why is because when we give flowers and we hold flowers, we don't hold them like this. We hold them like this. And the reason why is, as you probably know, the Netherlands are extremely cheap. We don't like to spend any money, we want to save everything. That's what we do. When you hold flowers like this, they remain fresh much, much longer. So when the Germans came into the Netherlands, what did we do? We offered them flowers, and they walked away like this. And then we knew that they were the enemy, and we could capture them. It's a very simple stuff. Thank you so much.
Do you have any similar tip for methanol and ethanol? Okay, next we have Prakriti Sethi. Can I welcome you for your context setting, please?
To thank the Institute of Marine Engineers for sort of inviting us. This has been an immense pleasure to have you all here, because the kind of interest that we have seen on methanol, I mean, the moment we entered the room, we were quite taken aback by the kind of response we have seen today. So we see that definitely there is an interest to understand about methanol. So I just would like to give you a round of applause for all of you for being here. Thank you so much for making this event a good segue for us to understand where we would actually go forward with this discussion. But I think with that, I would also like to thank our chief, those inspiring remarks, and for joining us today in his busy schedule. He could make time for us. Thank you so much, sir. So I think in terms of what Alex has also mentioned, just to give you a segue, what India is doing with the kind of different projects, especially the Sagamala project, and the kind of green fuel impetus which is given by the government on National Green Hydrogen Mission, and a couple of projects that I would also be speaking about with regards to the fact that they would also be looking at carbon capture utilization. Those are different schemes. I think before I delve into that, I'd just like to make it very simple for you to understand what's really happening globally and what's paving the way. So I think the reality of it, how it's going to work, what are the challenges, and how India could also look at these opportunities, looking at the kind of vast coastline that we have, how we can make use of those opportunities. I would like to move forward with my introduction of METHANOL Institute. I do know that a lot of people would know about it, but just to give you a glimpse that we've been connected with different offices around the world, and that gives us an impetus that yes, we do know where things are moving ahead globally, also understanding different markets regionally as well. So we've been in industry for the past 36 years, and our main goal is to sort of look at how we can promote the methanol industry, both on the supply and demand side. So we actually connect, as you see on my screen, these are our member companies. We are a member-driven organization. We are the connecting dots for different value chain stakeholders of this industry. So you would find methanol producers, distributors, technology providers, and straight away coming down to the demand side, which is obviously a huge chunk of the shipping industry that we see here today. So yes, there's definitely an interest that is coming from all sides of different sectors. Just to give you a glimpse of what exactly is the supply side on the global level front, it's about 93.3 million metric tons, so about 117 billion liters is being produced annually. And this is today that I stand saying that, which is eventually is going to grow, as Sir has also mentioned, that we do have a lot of immense opportunities, not just on employment generation, but also to reduce the reliance on looking at petrol or diesel. So you would also find that there are different sectors that methanol goes into. Predominantly, it's the chemical sector. Most of it is looking at formaldehyde, and then eventually it would go to certain sectors, including the fuel. But it's mostly looking at, also on a global level basis, would be the chemical sector and then pharmaceutical sectors. These are the two main areas predominantly that methanol was already being utilized for the past couple of years, and now eventually it's going to alternative fuel applications as well. So this is the methanol production pathways. I do understand that there have been a lot of discussions around grey, blue, green, bio. So there are different color coding that industries have given, depending on the kind of source they're looking at. But so as to put it together, there's not a defined definition of a color code. It depends on the kind of feedstock that you look at. So on your screen you would see different color coding that we have given based on the feedstock. It would also depend on the kind of regulations that you're looking at, because the EU would be very different from what we are thinking in terms of internally in India, and regionally obviously it would also differ when we talk about different countries looking at regulations on the carbon emission. So grey and brown would eventually be under the grey session, which you would look at. It would come from either natural gas or coal. And eventually we would move to more greener feedstocks, which would include agricultural feedstocks or municipal solid waste, which would be covered as under biomethanol. This is a generic definition that we usually use for the methanol industry, not in terms of any regulations that I'm quoting at this point of time. And then eventually when you move to looking at reducing carbon emissions from capturing carbon dioxide from power plants, like the CCUS deployment, it is covered as blue methanol. And then we would eventually move to green, which is the E-methanol, looking at green hydrogen and captured carbon dioxide, which is the greener way to move forward. So these are the different pathways that we will be looking at, and as you can see on your screen, the kind of investment that would be required to be looking at a future which is completely green. So yes, definitely the price point is there, but I think it's eventually there for any new fuel that would bring in. So we need to sort of hold hands together with the industry and the policymakers to get that kind of scalability to reduce that cost. Just to give you a context in terms of the methanol supply in India, this is a chart that was by Niti Aayog. As you know, that they have a very robust program on methanol economy. And why I say that, because there are few countries who have come up with a program specifically on methanol. So definitely there is an interest, and they have looked at different production plants that are coming up and that are planned. Most of it would be looking at CCUS at the power plant facilities. Specifically, NTPC is also doing that, which I'm going to talk later in my slide. And then natural gas production is the immediate solution, which is available for low carbon methanol production pathway. We do have 3 to 4 methanol producing plants in India. One of the biggest plants is Assam Petrochemicals. They are producing close to about 500 tons per day. And they have had quite a few tie-ups in the past, and they're looking to expand the capacities as well. So you would find the domestic capacity at this point of time would be around 0.8 million metric tons, and the demand is obviously is to grow, as Sir has also mentioned. There's immense opportunities that lie ahead for the methanol industry. So 2.5 million metric tons would be what is the demand, and that is required at this point of time, and eventually it's going to grow. This is the demand that we need to cater to, which we are not, and which is being sort of met by the imports. So you would find 80% of the methanol is being imported from the Middle East. So that is something where we need to really chip in and understand how we can make the Atmanirbhar Bharat mission successful. So most of it, as I mentioned, it is utilized for the chemical industry, but it's eventually growing. And we see the demand would mostly look at shipping industry, which is obviously the primary area, but we would also see fuel cells coming in as one of the areas of applications for the methanol. One thing that I would like to note here, which is very significant for us as an industry to understand, that there was a study which sort of came out at Economic Times, and it said that if we can capture about 0.25% of emissions from the point sources, we can meet India's methanol demand without importing. So I think that's something that we need to really consider, that how we can look at, we have immense opportunities of utilizing the carbon emissions. We have a lot of power plants. We can utilize, we have the sources to produce methanol. So why not just utilize that? So I think that's where we really need to look into. Now we move to the green methanol part, which is the talk of the town since the launch of National Green Hydrogen Mission, which has also given a great impetus on looking at green hydrogen derivatives. One of it obviously is methanol. And I do believe the Shipping Corporation of India, they have been given a mandate to look at how 2 ships can be run on either green hydrogen or green methanol, but I do know that they're quite keen to take up green methanol. We have had discussions in the past as well. So we are hoping to see a successful retrofit from there as well. So definitely there's work going on. It's not something that it's the talk of the town, but yes, work has been started, and there is definitely an interest coming from the Indian side as well. One thing that was important for us to understand why really green methanol was also on the table. Obviously, green hydrogen is there, green ammonia is there, but why India would be looking at green methanol was very important for us to understand. So as to cater to the demand was the fact that a lot of stakeholders told us that we do talk about price, we can get the price down, but we do not talk about the off-takers. How do we balance that? Obviously, we have a lot of opportunities in refineries and fertilizer sector, but there's a huge chunk that we sort of miss, which is about 11% of the demand that is coming from green methanol that we want to cater. So that is like the highlight of the stakeholders that people have come up to us saying that we need to cater to their market, because everyone else is obviously looking at ammonia, and fertilizer industry is obviously huge. But then we are not even looking at something which is 11%, which is considerable to look at. So I think that's where we also need to look beyond other, prominent and existing sectors which are looking at green hydrogen deployment, but also methanol industry is one of the way to go forward as well. And the highlight also would be on this slide would be to look at different state ministries. It's not just looking at the government or the industry coming together. The state is also moving forward in terms of having their own state policies. So some of the progressive policies have come from Orissa and Kerala. So Orissa is looking at becoming one of the biggest hubs for green methanol production, and they've made a lot of announcements around that. So I think that is something which is to look forward to. These are a couple of announcements coming from India to look at the green methanol market. As I mentioned, Orissa obviously is there. So there have been a lot of discussion to have methanol plants, especially coming from Renew Power. And then you would find something happening on the Tamil Nadu front. A Danish company, Umwelt, sort of announced that they are looking for a plan for about $850 million to produce 1 lakh tons of green methanol annually. So I think there is definitely scale to move forward, and they're looking at production of close to about 500 megawatt solar plants that will produce this green hydrogen and then eventually green methanol. So I think this slide just depicts the fact that yes, the industry is moving forward. they do have plans to look at green methanol. And the reason why I say that, because the study that was done by some of the industry stakeholders, it said that the estimated payback for these plants, for these green methanol plants, would be close to about 11 years. So yes, there is a business model behind that. It's not something that they're doing just because they have to do it, or it's a mandate coming from the government. They definitely see an opportunity. They are backed by the government. So I think that is also a business case for other industries to take forward as well. This is a glimpse of what's happening globally. So we track on a monthly level basis. We do update it very regularly. We have a tracking board on our website, which you can also have a look at. We track different renewable methanol projects that are either being announced, commissioned, or at implementation phase, or the FID phase. So it depends on where exactly or what exactly is the timeline of different projects that are happening. So as you would hover around different countries, you would find a lot of information on that. And based on those observations, we are working with Jena Solutions, which is our member company, and they have come up with certain graphs that will be viable for you to understand that in the coming years, we would see a huge chunk of E and biomethanol plants. So you would see on your screen that eventually it's going to grow to 35.7 metric tons by 2030. So that's growing. We update it. So based on the kind of interactions we've had with different stakeholders. So it's a very ground level study. It's not something only based on the news, but we interact really closely and regularly with the stakeholders to understand where exactly the market is going. So eventually we would see the share of e-methanol would increase and would be equal to looking at biomethanol. Eventually biomethanol would, in the short term, would be the viable pathway to move forward. And then we would look at, once we get hold of the production of green methanol, green hydrogen, eventually it would pave way for green methanol as well. This actually depicts what different regions are doing in terms of the production capacities of renewable methanol. And obviously, China being the biggest market for methanol, conventional methanol as well, and the consumer, it will definitely lead. But from this graph, I would like to also say why China is also leading is because of the fact that they have the resources as similar to as India has. We do have similar dynamics. We need to sort of taper into that. And the reason why I say that, because we have huge, immense opportunities for renewable electricity. So I think that is something that we need to look into, which we can tap. And I do believe that one day we will also have India on this map. And we see that Europe is also moving forward, obviously because of their regulations on board. There's a lot of focus on how renewable methanol would be taken up by the maritime industry and on different sectors as well. But there's a big focus on the policy advocacy at this point of time in Europe. This basically talks about the future trends of different projects that we have captured at this point of time, depending on the kind of phase that they are in. So you would see, eventually we would see at least 85% of e-methanol, converting it into more of feasibility, pre-feasibility phase at this point in time, but converting into more under construction. So this is the reality at this point of time, looking at where the projects stand. It's not just the announcement, but at what phase they are at this point of time. And the next, the side graph on the right hand side shows exactly what the phase would look like eventually by 2030. So we do see that there's going to be a huge increase in terms of looking at implementation of green methanol projects. But yes, there's still a little bit long way to go in terms of the implementation. These are some of the biggest players who are part of the renewable methanol industry, who are looking at producing green methanol. And it's not just coming from one particular sector. You would see project developers like carbon recycling, liquid wind, And now also oil and gas companies like Total, Sinopec, Shell, they're all looking at how they can produce either low or green carbon methanol. Green methanol, sorry. I think maybe Khil would also go through this. There are a couple of examples on what the world is doing. And this is what is happening around the world. I mean, the numbers, I'm quoting the numbers here, the discussions that we've had in the past. So there are huge numbers that you would see that China is doing. One of our companies, CRI, they're looking at a plant in China. So I think I would like to skip that. That would be covered by Khil as well, in terms of looking at how different companies would be looking at producing green methanol. So Goldman is one of the companies that is looking at green methanol production, and they have sort of looked at 5 lakh tons per year for renewable methanols, which is huge. So I think this is a company to look forward to, and how they would be adopting the production of green methanol. With Musk, obviously, Musk being, I think they have sort of changed the tide of the shipping industry, wherein they came up with such an ambitious project to adopt green methanol, and that sort of has led a movement around the shipping industry to look at how methanol would be utilized. So I think Musk has been the leading factor in terms of moving that tide, but yes, we do see everybody else also joining in hands with them. The safety aspect, which is also very important, I do understand that Sir has quoted previously, you heard about these methanol poisoning events, but yes, safety requirement is the first thing when we look at any project. And there's also the question when it comes to, I get that question a lot of times, is it really safe? So one thing that I want to sort of mention is that it's as safe as petrol or diesel. You don't ingest it, right? You would not ingest it, and it's as similar as that. And in terms of safety assessment as well, there was a consultancy which sort of gave out a report on safety assessment on the future fuels. And methanol stood at the end of the table. So I think that makes a lot of sense for us to reflect where we are really moving forward. What's the problem? Is it safe or not? Is that a problem? Or is it something else? So I really want to, I want to open the floor actually. It was supposed to be a presentation, but I want to make it interactive. How many of you do you feel that safety is a concern? I will give out 3 options. What are the barriers? And I want to understand which is the biggest barrier that you find that, that's the hindrance for the methanol industry. Do you think safety is a concern?
Yes.
Okay, so why do you think that?
If you see the flashpoint of its age, and so the challenges would be the flashpoint is lower than the traditional. Add to that, there are certain materials it's not compatible with. So adding the two together, now again it's far more safer than ammonia or
That's
other
what, yeah.
component. But if you compare with marine diesel or marine fuel, it's slightly the hazards are more. And then again IGF code caters for that, making it inert. The fuel tanks can be made inert. So there are solutions.
Yeah, that's what I was trying to say, that there's going to be like how you compare it. So ammonia is obviously there, which I don't think is at this point of time really safe, and we do have solutions. So we need to look and really comment that it's not completely safe. We do have solutions, and that's what we do, which Khil is also going to talk about. So we do have solutions. We just need to look at the solutions rather than looking at those as a challenge or a barrier. So the shipping sector, I believe Sir has already mentioned, and even Alex has mentioned in terms of what India is doing on Sagamala project, but there's immense opportunity. One thing that I would like to highlight, that Kandla port has also been a lot of force in terms of moving forward with the methanol industry. So you might have heard about them signing an MOU to look at having a methanol bunkering facility at the Kandla port. So this one thing that I wanted to highlight in terms of the shipping sector, what's happening. I think in the interest of time, I would, because I do have a couple of points that I wanted to add. But I think there's significant interest, not just looking at a global level from the maritime industry. But I think if you look at the domestic priorities, Indian waterways would be a thing to go for India at this point of time. We have had discussions in the past as well with the Indian Waterways Authority, and I think they feel that methanol is going to be a very promising fuel. So I think green methanol would be a very, very big opportunity for Indian waterways, especially when you look at the northern part to it. So I think, yeah, India would be looking at a lot of other opportunities beyond what we think Singapore or Rotterdam is doing, but internally we do have things that we can look at. So I think India should be looking at inland waterways as one of the biggest opportunities in moving forward to adopting green methanol. I mean, there are different challenges, and as you said, safety is obviously, there are concerns, but I think with challenges comes with solutions. So just to sum up my presentation, I do feel that we do have challenges, and that's the reason this is the forum which will sort of give us kind of a segue to understand how we can address those challenges and come together. So I think collaboration is key. We all are working under different priorities, but I think we all need to come together and join hands to understand how we can, sort of bridge that gap and connect those dots to sort of adopt, these alternative fuels. It's not just for the methanol industry, because I do hear that everyone, somewhere or the other, different value chain stakeholders are working on methanol, but they all are facing different kind of challenges. It might be coming from one part of the value chain, and they might want to get connected to the other part of the value chain. So I think it's very, very important and imperative for us, and this platform would give us an overview in terms of how we would want to move forward. So I think with that, I would like to conclude my presentation, and thank you very much for having me.
Thank you, Prakriti, for methanol. There was one slide, one part you said ROI is 11 years. Do you think anyone will do that for 11 years? ROI, it's too high. Yeah. Sort of. But if they push it to, because we have so many power plants, cement industries, if they can push it, that way we can definitely achieve. Right, so after the commercial part, we have Kel here, who is going to touch a chord with us, all engineers. Welcome, Kel.
Ladies and gentlemen, thank you very much to the Institute of Marine Engineering. It's a big honor to be here, to be quite honest. How to start. I also like, first of all, to take you through a small journey of 40 years. I retired from METHANOL 2 years ago, and I have been working with two-stroke engines all the time. When I came in 1983, then we started actually looking at dual fuel engines, two-stroke. It took until 2011 before the first two-stroke, and it was LNG engine, was actually sold. In between there was a lot of development on safety, hazard investigations, explosion studies, and so on. Gas on vessels at that time was, wow, this is a big step. But we reached it. It was much easier when the next dual fuel, which actually was methanol, where the first sea trial for two-stroke was in 2016. It was much easier. It was not organic. It was simple, known technology on many of the parts. The external part was very, very easy compared to the LNG part. Then we came afterwards with the LPG, no, not the LPG, the ethane, and then the LPG, and now ammonia. METHANOL are looking at ammonia, and in a few years we will see the first of those operating. But of course there is a big difference when it comes to safety. And I fully agree with your question before. There is a hazard, definitely, to overcome also for methanol. It's more simple, and there are you can say, there are measures around it, so you are safe with the tanks, the low flashpoint fuel and so on. I've been chairman of the CMAC Fuel Oil Group for 30 years, ended up just before I stopped at MAN, and it has been a fantastic journey. And here we started actually you can say the discussion and evaluation of safety and making a specification for methanol, which actually ended up being finished here in October last year, coming out 1st of January this year. So I will start my presentation, but my point is it takes a long time to develop engines, and now we are here, we know the technology is there, and this is something I would like to share with you, how we have considered and designing, and the complication, and also the answers. Yeah, I will skip that one. Oh, this is the one. Yeah. I will skip this one because that was from an old one. Here, see, the fact is here that 80 to 90% of all the goods transported is transported by ships. I think this is an extremely important point, and of course we all know. And 3% of man-made CO2 is coming from the shipping part. But I'm extremely proud to be part of the marine also this time, because this is the industry that is really doing something when it comes to the decarbonization. That is the group here. If we're looking at vessels and ships and so on, you will see analysis and reports saying about 100,000 vessels and so on. And who is actually the contributors to all this CO2? I have not made a formal calculation, but my guess is that 20 to 30% of the fleet is making 70 to 80% of the CO2 emission. We're looking at very big vessels, very big engines, and we are looking also at a lot of smaller ones. In the world, two-stroke, which is normally over 2,000 deadweight ton vessels, if it's not ferry boats and things like that, then these vessels, they will have two-stroke engines, and these two-stroke engines, there is about 30,000, rough figure, 30,000 in the world right now in service. Out of those 30,000, then about, you can say 22, about 1/3 of them is electronic control engines. 2/3 are the mechanical ones we know, with camshaft and so on, operating and not electronically controlled, and with hydraulic activation. So it's a lot of vessels we are talking about, but please remember this, there is a small, relatively small group of all the vessels that actually make a very big part of the emission. This is, you can say, also thinking in that direction, maybe it's not the right approach we are doing when we are looking at where to start in the decarbonization of the world. That's another one. See, we do in METHANOL Institute, at an early stage, we also, when Green Corridors was founded, we went in and are now also working with different green corridors. We see that as a way to accelerate the decarbonization. In the green corridor, you typically have 2 harbors. In those harbors, you know that box ships, like container vessels, they are operating in between these 2 harbors, and you can try to plan, as a pilot project, you can try to plan the logistics, the safety, the bunkering, the production part, how can that actually work? And based on that, you can use these pilot projects all over the world in a different way. We are part of what we call Nordic Roadmap, which is ministers in the Nordic countries making that. We are a member of Silk Alliance, which is going out from Singapore to different places in the world. Lingang pilot we have from China, and we have the biggest one we are part of is Rotterdam, Singapore. We are working very much with the authorities there. Very learningful, and as you can see on the right side, there is a lot of these things that is considered like certification, which is one of the items and areas also for IMO and also for EU. Policy papers, we have established reference values, all these type of things. When you make these projects, it's much more down to earth. You know what the challenges is and you can work out from that. We are looking into bunker and safety handling. We have done a bunker study which is public. Also, you can say a forerunner for IMO and ISO part of the standardization of bunker standard, which is not there yet. It's actually conducted by STMF, but we have been part of that. That also. We have also been part of the methanol standards, and I've been. We have been sitting in the committee there after I stopped as chairman there in MEIN. We continue to be member also to have an influence. Generally, what we are doing on the technical side from METHANOL Institute is actually to be technical advisors. We are also the specialists, not only when it comes to the general technical part, but of course also the supplier and this whole chain we are talking about all the time. So therefore we are represented many places and really believe that we have a big influence, like the IMO part, which is already talked about before. I'll jump these because then Prakriti have already talked about this one. Sorry for that. There was a good win. Yeah. See, just for somebody not having been on board, this is not small sewing machines we are talking about. Here we have on the left side we have a smaller engine. It's a 35 centimeter bore engine in the cylinder, and then we have a 95 bore or 90 bore engine, which is one of the biggest ones. The biggest one we have in the market today have a weight about 2,400 tons, and they have an output about 83 megawatt. Fantastic to look in a test bed and look at a test bed at a licensee, the Indian builders, see what actually come out of it. It is an industry where you see dominating, if we talk about two-stroke engine, dominating by Vintage and especially MEIN. MEIN have the last 30 years have 80 plus, about 80 plus in market share, so quite the dominating part. But all the engines from both companies are built by licensees. It's in Japan, it's Korea, and it's also, of course, in China. Sometimes I wonder how it could happen. The first licensee on two-stroke was Mitsui in Japan. It was in 1926. I still wonder how they were actually getting the drawings. It was a very big pigeon or whatever it was to send it out. It was what had been very complicated anyway, but it works. So looking at the engine and methanol engines today, you see there's quite a number of OEMs that have actually gone into the market and taken up the fight. If you talk to the OEMs, which is not on the list here, you will find out that these OEMs are actually having test bed where they are still trying their technology, but not yet put it into a catalog. So again, we have engines in the market from 100 kilowatt up to 82 megawatt for the marine side. In between, of course, there's all the gensets, which also is important, not only for the vessels, hoteling the vessels, and all the electricity used on the vessels, but also for powers, diesel power plants, as you know you have a lot of in India. If we look at efficiency of a two-stroke engine, you will see here on the horizontal line, you will see the years, you will see the gram is specific fuel oil consumption on the left side, and you will see, in according to the ideal Carnot process thermodynamically, you will be around these 150. You will see the SFC, the fuel oil consumption, how it has been going down. But now we are actually close to an area where you cannot take thermodynamically a big step. You have to take, you can squeeze and squeeze and squeeze, but there are thermodynamic limitations. And if you look at a two-stroke engine, it has quite an overshoot of oxygen in itself, because the oxygen intake is also part of the cooling process in the combustion chamber. So, NOx, that's something we do not talk about here, but what can you do then to improve? Okay, one, yeah. Then I needed two. So you see the ideal Carnot process here, and you see the rating, but there are limitations. We cannot make a mega step here on the diesel engine, internal combustion engine. So what can be done? Yeah, this is what the world is looking at now. Of course, there is, in order to have the decarbonization, that is to have the new fuels as methanol, but that's also to look at air lubrication on the bottom. I'm sure you have also looked very much into this. There is sales. There is also, you can say, what we call waste heat recovery systems, which was used already in 1889 by Müller-Maersk on one of the first series, M series, and where you actually increase the efficiency from 50% to 55%. And how can you do that? Again, you have so much air, you have a lot of heat from the engine process itself. Why not take and utilize some part of that? Just for the technical interest, I will just go a little bit through this. You have the two-stroke engine here. You have the high efficiency turbochargers. You take out a little bit of the stream here after the engine process, go into a power turbine. The rest and far most of this exhaust gas is going to the boiler. Here you take out steam and you put it in a steam turbine, which is connected to the power turbine and a generator in between. So actually it gave 5% more totally in efficiency. Today we are at 55%, or the two-stroke engines are at 55% already. So you can say it is less, maybe you can get out percent-wise, but we have actually thermodynamically calculated what is the optimum you can get out, squeeze out, if you use other technologies like turbines and so on in the total loop here. Then you might come up with a two-stroke engine with 63% in efficiency. But then you have not only a simple two-stroke engine, you still have the simple one shaft, one propeller and the engine itself, but you have a lot of equipment outside which also have to be maintained. And is that really the way to use the money and so forth? But we have to acknowledge that every gained efficiency point in the future is worth much more than it is today with the fossil fuel, because the cost of this fuel will be higher somewhere. So that means also the payback time will be shorter, and we'll see much more of those different things going in. But coming back to methanol again, it is out of these 4, 5 different fuels I talked about before, ethane, LPG, LNG and so on, methanol is by far the most simple one. And later on I will show you a little bit about the cost for investment if you use methanol instead of one of the others. There are engines like 4-stroke gensets here on methanol. There is the 2-stroke, and we have, you can say, gensets here. We have 4-stroke with propellers and so on. There in between you of course need a gear in some way to have the right revolutions. You have also here the dual fuel diesel electric solution we also see we can utilize on methanol. We have of course still the two different processes. We have the diesel principle and the Otto cycle. Here we have you can say still continuing the diesel principle. You take out the inlet air in the bottom. You have the piston here. The piston is going up. You have a swirling and also part of the cooling in the process. You also cool around the exhaust valve in the middle here. You have the injection when you are on the top, and you have the combustion of the engine, and you have the high efficiency. Then we have the Otto cycle. We know very much from 4-stroke engines where you have an injection and mixing of the inlet air and the fuel on the way. It does not need to be here. In this way, it could also be, like we know from the carburetor on a petroleum or benzene engine and so on. But it's the thing is that it's mixed with low pressure and it's burned when up here in the process. This is, if we look at LNG, this is one of the reasons why we have a methane slip, which is discussed so much, and also in IMO in a special project. Because if you use an Otto cycle, you will have boundaries of you will have boundaries. Here you mix the gas and you mix the air. You will have boundaries here where you will not have the best combustion. You will not have an optimum. You also have sides between the piston and, you know, above the piston rings, but still in the side of the piston, you have cylinder liner and you have the piston. And in here between, there will be methane that will not be burned. So here in the diesel process, you have a very, very simple and very controlled process. You inject the pilot oil into the combustion chamber. Up here, it burns, and then you inject the fuel directly into it, that's methanol, directly into the burning flame. So you know when and how it will ignite. This is a two-stroke engine, MAN. I think it's about a 70 bore engine. And if you look at the top here, you will see what is popping out here is the add-on for a methanol engine or an LNG engine or what it is. When I say add-ons, it's because the engines sold today as simple fuels, like fuel oil burning engines, these are all capable of later conversion to a dual fuel. It's exactly the same engine. So if you say, I have a methanol prepared engine, yes, you know, it's the same prepared engine that you can actually change to being for LNG, for, you know, the other different fuels. Just so you know, there's not particularly changes or preparation for the different engines. But also looking at this popping out being an extra injection system, the engine in itself is exactly the same. The control system is exactly the same, but with add-ons, like the physical extra injection system here. Another thing, not only if we look at CO2 neutrality when we are burning e-methanol or biomethanol, we also have, of course, reduction in SOx. We have the reduction in PM particulates. We have reduction in NOx, depending on how you lay out. But in the natural way of the burning process and the chemical process, you will have about 40 to 60% less NOx from such a methanol burning engine. You can optimize it to have even a higher efficiency. You can optimize it in a fuel mode. That means you have to reach the Annex 6 Tier 2. And if you burn your methanol on a standard engine optimized, you will have a lower level of methanol. If you then adjust your engine up to reach the Tier 2 Annex 6, you will actually have an improved fuel efficiency. So today, if you look at the catalog from VJD and MAN, you will see that the highest efficiency you can get on an engine is actually a methanol engine, higher than the single fuel engine. And here we have the process itself. I talked about the injection of pilot oil, injection of fuel to have a controlled burning process, but it's of course mandatory that you have also the fallback scenario where you have the diesel fuel you are using. It's also the same that you are utilizing, you can say, for the pilot oil. One thing in the future, I would say, it's very likely to become, is that you say, okay, you have a methanol engine, 95% is methanol, and then have 5% still being fuel oil. Yeah, it doesn't have to, because actually biofuel, as we know it, is also adequate to utilize as pilot oil. And then you will have a full 100% neutrality. So that is maybe the most optimal way for us to actually use it worldwide. But let's see what happens there. See, we have been through some part of it. Another thing with the simplicity of the methanol engine, it has a supply pressure at 13 bar. You know, in the tank itself, the service tank you have, which is normally 12 to 24 hours of service, then you will have atmospheric pressure. You have nitrogen also in the backup, the basis on the storage tanks and so on. And you will have the 13 bar at inlet to the engine. Here it will be boosted up to 600, I'll come back to that. And what is also worth mentioning, all the dual fuel engines do not go below 10% load. If you go below 10% load, it's difficult to control both the engine process itself, but also how much pilot oil is really necessary compared to the amount you have of the fuel oil, like in this case, methanol. But it's not different from other dual fuels. It is 10 to 100% is what is always used. That means also, we talked about safety before, when you go into a harbor and you go below 10% or before that, you actually change to fuel oil. And that means also that when you go and are in the harbor itself, you don't have methanol in your pipelines on the fuel oil. I will show you that, I will illustrate that. See, I think I have a better one like this one. See, again, thinking about the add-on extra fuel gas supply system added to the engine itself, this is how it looks like in more detail. We have double wall piping, and as soon as you go into the engine room, you are going to an explosive safe area, and then you are using double wall pipings. So we have double wall pipings going here, and this is one cylinder head. This is for each cylinder, this extra add-ons. You go in, you have the inner pipe here goes into the control box. You have lines in the cover here, so you have no open pipeline there. Also in safety mode and safety aspects, you have the methanol supply from here. Then you have, because because it's liquid and you go from 13 bar, you need to have 600 bar when you inject it into the combustion chamber. So that means also you have separate valves, and here also booster pumps included in this. So you both have an injection valve system part, and you have a booster part, which is quite simple because it's a matter of have 13 bar coming in, and you have a big piston on top and a small piston on the bottom, and this is giving the high pressure control. Here you have some accumulators and so on to ensure that the pressure flow in the system is maintained in the right way. I talk about MAN because I've been here for so long. Sorry. But not to forget, they are not the only one. And here at Vintage, we have investigated their way of doing it. It's quite similar. Also when it comes to the efficiency, solar efficiency when burning methanol. So it's the way it's going. This is just to see a little bit about what MAN have produced of different engine types. Here you see a huge number of LNG for LNG, but have to remember LNG carriers are using the goods, the boil-off gas from their tanks. So this is for all new LNG carriers will be you can say, with 2 engines using LNG. Methanol is coming up very much like this, and I'll come back to the total number. We have the LPG or MENHAP, we have the ethane, and then the GA, which actually is Otto cycle, believe it or not, but an Otto cycle also for LNG carriers. That's another question. It's a matter of, one thing is emission, but even for the bigger companies, the money still talks. So, see, when you go in and you make safety considerations, as it has of investigations, you do that with all the different classification societies because they are representing the flag states, and you do that way before your engine is ready to be put into the engine program. But you see all the differences here, which also make a difference both in the injection system on the engine itself, but also the external fuel supply system. Is it cryogenic or non-cryogenic? What pressure and so on? What is the low calorific value? What is the volume we have to put through the system? So for instance, for methanol, the pump valve you saw before on the top of the cover is about twice the size as it is with diesel because of the larger volume that you have to inject to get the same power. So also the supply pressure here you see is quite different. 8 and let's say methanol 10 to 13, it's in that area, both of them, where MGO is here and normal diesel, very, very close. And also if you look at the system, design of the fuel gas supply system, it is very similar. You have the engine here, you have the gas safe area here in the engine room, you have the double wall piping starting here, then you have the tank, you have pumps, you have heaters, coolers, filters, you have the fuel valve train. The fuel valve train is the extra part you put on when you have dual fuel engines. This is controlled and connected to the engine control system. Therefore, it's also typically supplied from a supplier that is working together with the OEM. So when you go into, let's say as we talked about before, you go to a harbor and you have to change over to fuel oil at a certain load, then what you do is you stop here, no supply, and you have recirculation of the methanol. Then you take the nitrogen supply and you purge all the piping, all the system here, and you purge it and you go back to the tank itself. There could be, because of sealing oil is used in the system to have, to ensure the gas or the methanol is not going the wrong way in the system and design of the fuel valves. This sealing oil can still have some methanol in it. And what do? We use the simple gravity in the tank, where you have separated the tank in two. So what you get back, you can actually take out in the bottom of this small first tank, you can take out what the oil has come in, and you can overflow the methanol back to the system. It's very, very simple. See, I talked again about this small add-on to each cylinder, this new methanol part for injection and so on. This is also why there is the possibilities of retrofit. Retrofit of engines, and typically you see here, the first one is the very big vessels. If it's a small vessel or it's a big vessel, it's the same equipment. It's the same equipment as we saw here before. Of course the size is different, but it's the same system, and that makes it also, when you retrofit an engine or a vessel to operate, for instance on methanol, it's relatively much more expensive on a small one than a big one. And here we see the big one where, again, due to the size and the power output and emission, it's make much more difference in the decarbonization by starting with these big guns here. We have A.P. Møller, Maersk, CMA, CDN, we have COSCO, we have C-SPAN, and it's quite a number of vessels we are talking about, and a lot of CO2 savings. Of course, this is when the e-methanol and the biomethanol is available. But also, as mentioned here before, we have to understand, all of us, that this transition will take really a long time. So therefore, on the technology part, we need to use all the different technologies. We need to develop a carbon capture unit that can be on board. We need to improve the efficiencies you have seen today. The technology is there, but it can be much better thermodynamically, chemically, all the different things which is necessary to explore and to build up. And also, one of the reasons why we are saying what we call the blue methanol, why do IMO and EU not accept this way of reducing considerably the CO2 in a long number of years? Because we need all the technology to have this process going efficiently. Otherwise, it will take much too long before we are really there. Because this is also a thing we are working on in that respect. If you make a retrofit, it's not as simple as it looks here on the slides, because what you need is a yard. They need to be contractors of the system, you can say. They have a part which is the outside engine. On the engine part, it's normally the OEM taking care of it also. But as all different processes, the first one takes a long time. It's a learning process, and I would say the OEMs is still there. But it will be much more normal in the future, I'm sure, and it will be a lot of opportunities for yards actually to make this process. It's not something that the engine builder normally take care of, just the engine part. It has to be a yard who can make all this steel work and installation of the different components and so on. So there's maybe also a business opportunity in the future. If you look at and compare what is the price if you have an LNG vessel or you have a methanol, there is this simplicity we have talked about before, and the technology already being there on the methanol part and not eugenic. You will see that for this vessel, it was a study when I was in METHANOL. We from METHANOL, together with METHANOL INSTITUTE, Hyundai and DAV, we made this study. Hyundai have already delivered maybe 15 methanol carriers. So they knew about the installation and all that. They also have supplied these engines of vessel size for LNG fuel. So this was the result, and it is the result if you take the total price of the vessel, 10% extra if it is a methanol engine and not a single fuel, and 22 if it's a LNG dual fuel engine. Quite a difference. I'll not go in detail here, but this is some of the big container ships where you can also see what is the extra cost for the conversion. So, what is the situation today? I think this is incredible, and it is just going up and up and up. We have now 358 vessels which is with methanol engines. We also have, you can say, different type of suppliers, OEMs, and different size of engines. We have also, you can say, yeah, this is actually the suppliers here, and here we have the engine types. And what is also very interesting is that it is not only container vessels, it is the whole segment in the maritime world. So it's tankers, bulkers, car carriers, and so forth. So it's spread around. And there is a lot of top owners here with very known ship owners that of course have been through all this process we are talking about here when they go in and choose for a methanol engine. This is what is called ready, and ready for methanol is about, picking up for new vessels single fuel, but then also thinking, okay, in the future I do believe when it's there, the methanol, I will go in and I will make a conversion from methanol. And another thing we also have to remember, I pointed it out a little bit before, is that one engine, main engine, two-stroke, or two, seldomly LNG carriers, but one engine, but then of course you have 3 to 4 gensets. And these gensets are also converted or is also designed for methanol. Most of these, you can say, gensets, newer gensets you find in vessels, they can be converted also as the two-stroke engines. This is what we have seen from, I think it's ABS, this one, yes, ABS. It is about the same curve you will see from DNV, but if you go back in time, you will also see these type of curves, they change a lot. I have to say this has been the most confusing part the last 5 to 6 years. That is the crystal ball assumption and saying, okay, we believe this is the future, this is how it will be. But we all know that this is not correct. It will change, and obviously it changed a lot. So, but this is what we have seen for a very long time, that it will be something between you have ammonia and you have big part of methanol. Now I'm speaking about 2050. We will still have LNG. It started up now to LNG being bigger. We don't believe, or I do not believe, that it still is a final, it may be a final version for LNG carriers and so on, but I think that methanol and ammonia will end up being much more dominating. And we'll see there will also, the expectation is, there will still be fossil fuel there because we don't have time enough. But that can change, hopefully, you could say. We also have to remember, and I think this is very important, the situation that the ship owner always have. When we come to them and speak about technical issues and so on, say, Kjell, if you were in my shoes, what will you choose? Will you choose methanol? Will you wait for ammonia and so on? This is of course always a consideration about where is the supply, where am I trading, and so on. We have to believe that it will not only be methanol, it will also be ammonia. It will also, it's unrealistic to believe that the 200 million tons will be exchanged with methanol. And there will be area where it's much smarter to use methanol because it's more available in that area, maybe a lot of biomethanol in that area, and so forth. So let's see what happens. We do what we can to get in that mode and in that direction of decarbonization, for sure. I will not go into detail with this. I will just say that our presence in the EU forum and also in the IMO is of course to inform about what is the real case when it comes to production, logistics, safety, as we talked about before, also bunkering, standardization, and so on. We see ourselves as specialists in this, and as NGO in IMO, we talk about the countries coming to us, but also us speaking to the countries' representatives and say, why don't you look at this? This is the way to go forward for different dual fuels. And here is actually the situation, the technical specification, the opportunity when it comes to e-methanol and biomethanol. Yeah, this is, yeah, and where is it actually available today? The methanol, it is available in different harbors, but if we look at specifically the harbors, there is active bunkering already in all these ports, and this is under development, and there's actually also a few missing on this list. So the availability is of course essential. And coming back to the green corridor that could accelerate the whole use and introduction of the methanol and decarbonization, it's a very good tool. So thank you very much, ladies and gentlemen. I hope you enjoyed.
Thank you. Can I request?
Good afternoon to everyone. This is Govt Of Insight. Thank you, and the Institute of Engineers also for organizing this seminar. So I saw 350 ships, engines are on order for methanol, and there are many ships with the methanol as a cargo, having methanol engine, and there are many bulkers and container ships as well. What we hear is many of the ships, other than those who are carrying methanol as a cargo, not using methanol as a fuel, for the simple reason, unavailability and the cost. The whole idea of decarbonization of IMO's cleaner shipping mission is failing here. So the METHANOL Institute, have you got any plan or a blueprint how you will be making methanol available at a reasonable cost and available in quantity?
Yeah, that's the big question. How are we going to do this? How are we going to make it more available? When will be the cost acceptable, and a few things. Number one, it's regulation. Without regulation, it will be absolutely impossible to change anything. It's not only about what we are doing, but I think in general in day-to-day life, you need regulations to bring change. It's also about working together. You cannot say anymore, for example, India is just focusing on India. China is focusing on China. That's not how an energy transition works. It can work in different situations, but you have to work together, because what happens in China influences Europe, what happens in the US influences India. So you have to work together and you have to make coalitions. I'm not sure if you remembered, but one of the things I mentioned during the opening is instability is the biggest threat to the energy transition. I know on the politics side there's more stability in India, also in other markets, but you might probably have seen that what is happening in the West is completely different. So if you look across the globe on the political systems, Australia, every 3 years they have a new government. 3 years. Europe, 4 years. Brussels, 5 years. The US, 4 years. So you must understand that, and we talked about, for example, the return on investment. It was also a very good comment. As a ship owner or as a producer, you cannot rely on the government that might only support you for a period of 3 to 4 years. You cannot. It's a lot of money. You're all in a very risky business. You are managing a business. You are responsible for many people working for you. You cannot rely on the government that might say, you know what? Yeah, 2 years ago I was your friend, but not today anymore, because now we have other plans. That doesn't work. So we need the stability there. One final thing. It's not about producers, it's not about vessel owners, it's not about consumers, it's about the entire value chain. So, when you ask what is the price, you just mentioned what is a better price. What do you mean by a price? Is it the fuel price? Because the highest fuel price might be the cheapest one at the end of the value chain. So what you need to do is, every single step, you basically have to sit together. Therefore, it's also important to work together, and especially government needs to be involved in this. Sit together and go through every tiny step of the value chain. And it sounds like a horrendous procedure. It is, but you only have to do it once. Just go to everything. How much is it? What are the issues at board? What about financing? What about insurance? Where are the costs? Why are insurance prices so high? Every vessel is often insured by 4 brokers. They don't even talk to each other, they don't care. They just charge you a premium because you need insurance, because otherwise you're in trouble when something happens. But no one talks to them, so why not sit together and figure out how can we reduce all the costs? It's not only about how can we produce cheaper, but how can the whole value chain be more efficient and more effective. And remember, we often talk about fossil fuel, that it's all cheap and available and we can do whatever we want to. But it took years and years and years when they found oil to turn it into an industry. It took decades to make that happen. So why do we all think that the energy transition is a flick of the switch? It isn't. It takes time. And unfortunately, we're not doing it for ourselves, we're doing it for the next generation. That's for some very painful, but it's the reality. And that's also our blessing, I think, that we are part of an energy transition. No one else will go through this transition again. That's us. We have to do it all together. So look at the value chain, work together, then the prices will go down, for sure. Does that help? Yeah?
Thank you. Just a little add-on to you, Alex, about the entire value chain. We hear that the electrolyzers is going to be produced or is produced here in India, and I think that is fantastic. This is one of the big steps. We have also seen that the prices of electrolyzers have actually gone down because the competition, the natural competition, but also on the technology side, we need to find the best optimal solutions to come further on. So please invent.
That Alex has mentioned in terms of coming together, which I've also quite a lot of times reiterated. I want to give an example how things are set for Maersk. It's not the government that is backing, it's the customer pull. That was the main objective that they came up with, the fact that we want to do green methanol. They are the biggest shipping companies, but they could not do it alone. They have closed about 10 partnerships. They've come up with their own subsidiaries looking at production of renewable methanol. They have the Maersk Material Wellness Center. So it's not the fact that they're doing it solely. They also need the support of the whole value chain, and they cannot do it alone. I think that is an example to look at how we want to understand the interest and how we want to come together. So I think that makes sense to look at what are the challenges, how we can come together and look at connecting those dots. So I think that is an example which I wanted to quote in terms of a practical example. It's not just a talk the town that we're doing.
Got a very valid point. See, what happens is that you said that what is going to be the biggest constraint for shipping, is it safety or something else? It's simple. The industry is a commercial industry. They are running ships for profit, not for charity. So the simple point which he is pointing out, any scenario, so we are saying that we projected the scenario what is going to be 2030, 2040. We also projected the cost, maybe for the green, grey it could be, and more than 2000 plus for the green methanol. I feel it's for the vehicle. See, what happens is that ultimately the simple point which is to be answered to the industry, if this has to go, particularly from the learned organization like we, is that at what price and what kind of availability will be there for the fuel at the point. It is not a question of I understand the challenges, the production has got challenges, the supply chain has got challenges, the investment, everything is fine. But end of the day, if the industry has to take off, they have to have simple answer at what cost the fuel will be available to me maybe 2030 or 2040, and how the extent the availability there. Ultimately, the ships are not over. You make so much of investment for a engine or whatever the modification is there. End of the day, if you are not able to get the fuel, or if it is not available, if you are having a better result, he has to compete with the similar equivalent scenario in other companies. So the simple answer we have to give is what Francis asked. At what cost we will be projected. I'm not saying that it is a sacrosanct or something like that, but an informed institute like yours should be able to project what would be the approximate cost expectation, and what could be the availability scenario maybe in 2030 or 2040. That will be beneficial for the industry. That's what Francis was talking about.
I fully agree with you. Fully agree. At the end of the day, it's regulation. And I give you a very simple example. The fossil industry is being subsidized. So whatever they produce, money from governments is being added to it to be more profitable. If you take that away and you would put it on the green side, the prices will be even lower than what you're paying right now for fossil fuel. So you're absolutely right, but without regulation, without government support, it will never ever happen. Never happen. So you perhaps know that the Fuel EU Maritime will come up to swing, ETS, where there will be levies on fossil fuels. You will see that in the next 5 years the prices for fossil fuels will be challenged, and that the green prices will go down. Very hard. So for example on bunkering they have predicted that around 2040 that will go over 2,000 euros for bunkering, based on the levies that come in. So, and you're absolutely right, you're not a charity, you need to make this happen, but it is going to happen, because all the regulations are lined up, and the IMO will come with an outcome, hopefully in April, but otherwise it will be in May. You will see there will be a difference and there will be change. And otherwise, I have to go back and apologize. But I think it will happen. Yeah.
The question. So it is basically mostly the electrolyzer part towards production of green methanol. The electrolyzer is the important thing. So mostly it is getting imported. Is there any project which MEI is planning to have the indigenous manufacture of electrolyzers, which can reduce the cost?
So I think I would like to clarify the projects. We just facilitate to connect the dots. So in our personal capacity, being part of METHANOL Institute, we are not doing any project, but we will definitely support the initiatives looking at bringing down the cost. And to address the cost concerns, because being a trade association, we do not really disclose the pricing because of our member companies, but to just give you an example, if you talk about conventional methanol today, the range would be around 25 to 35 kg. The cost of green methanol, or I would say the blue methanol, which was done by NTPC, it was predicted that it's going to be 3 to 4 times higher. I understand there's cost concerns. That is there, that's the challenge. That's what we are trying to understand. Even the ROI also has reflected. We are trying to give you the real picture. We are not trying to move you forward with, okay, this can happen. We're not only promoting, okay, you have to adopt methanol. But this is the reality. And even in the graphs you might have seen, the kind of reality. And we keep on updating. It's not just we're posing it for the fact that, okay, it's going to increase. Eventually, as Guild also mentioned, it keeps on changing. We are also trying to understand the trends. But yes, the cost is eventually going to be increased at this point of time. But in terms of electrolyzers, yes, I do think there's been a lot of focus on having local capacities, but I think it's a little bit far-sighted at this point of time. And even with methanol, as you know, it's being imported, and that's what we are trying to bring in. We need to bring the local manufacturing capabilities on board at this point of time to improve the efficiencies as well.
I think just to supplement your query, Govt has raised. See, the electrolyzer per se is not relevant only for the methanol. It is for the production of clean hydrogen, basically. So, what going to be the question here is what is going to be the derivative fuel from so far as hydrogen-driven fuel system, I think there is a largely an alignment that is going to be there. Now the question is regarding the what would be the derivative side of it. So whether it is going to be ammonia or ultimately it has to be green. So I will just answer your query. It is not the question of whether we are going to import the electrolyzer or we are going to manufacture an electrolyzer. What of the end of the day, how far, as Francis was pointing, how far we will be able to get the affordable fuel at the point of delivery. So the Green Conclave, there were the meeting with the 7 of the CEOs of the green hydrogen products in India with the Secretary General of IMO. So I was there. So in that, I'm talking about the methanol part of it. They were very categorical and specific in saying that the green hydrogen will be available in the scale which is required at around $1.5 to $2 per kg. In effect, it will make the ammonia available, green ammonia available somewhere in the range of around 700 oil equivalent per ton. So that is what the competition which we have to offer from the methanol side. So this is not coming from my point. I am talking from the horse's mouth itself. The actual people who are doing it on the ground and producing it. So same card. If I am a ship owner, my point is simple: whether I have to invest for an ammonia ship or methanol ship. If one side we have a guaranteed one regarding the cost projections, the other side we are not able to give it, then the answer is obviously clear there. Now to answer to Alexander regarding the regulatory point of view, since I am unfortunately or fortunately happen to be the part of the regulatory side, both for IMO as well as for the Government of India. See, as you said, the levy, all this kind of thing which we are talking about. See, that is the point I was trying to mention, whether the organization, technical organization like IMO is moving away from their technical mandate to produce, do something which should have been done by a market-driven, a technical-driven solution through a political solution. Is it correct or not is something different. But end of the day, to answer to your regulatory part of it, regulation is not for something, creating something. Regulation is to moderate the situation to the overall goodness of the society as such. And to sound too simple from your point of view, through the levy itself, if it is going by if you are going to force any kind of green fuel through the levy which is going to be decided by MEPC 83, see, there is a straight, there is no ambiguity regarding what is going to be the flexibility or this kind of, it is straight 10 to 15% increase in freight rate for India. 10 to 15% of freight rate increase for a country like India, with the annual freight outgo itself is almost $75 billion annually, which is expected to be around 200 billion by 2030. What is going to be the additional cost which is going to be there? 10 to 15%. Who is going to bear this? It is going to be borne by you and me, the honest citizens. So when the honest citizens of this country, through their payment is going to be made, they also have the right to decide the priorities for a country. That is how the regulation comes. A country like India, where it has got still, there are so much of around 30 to 40%, still you can say that not up to the. We also have the right to have a better standard of living. We also have the right to have a better way of living. So if for the priorities has to be set by the government. So when the priorities are set, the regulations also has to be worth that. That is what the part for the regulation.
We have as well who are involved in conversion of 2 of the vessels in, as mentioned during conversation, into methanol or ammonia. Do you have any questions to the panel?
It's still being decided whether.
Decided. Who are the reps from SCI? SCMSA? You all are doing the same project with it. So anything that you need to pick up?
As far as SCA is concerned, it's already been decided that we'll be converting 2 of our vessels to run on green methanol. And the vessels are also identified. They are like 120-ton black pool vessels. And the feasibility study is also done. So we are in selecting the shipyard, and soon the contract will be finalized. It's on green methanol, that is finalized.
Conversion of existing vessel engines to methanol engine. What is, as a percentage of cost of the ship, what would be the cost of that conversion? and availability of engines is a big challenge as well for new building. We had a case in one of the shipyards in India. They were not able to find, it was 8,300 GRT general cargo vessel. They were, obviously it will be a 4-stroke engine. They were not able to find the suitable engine in the market. It was, the waiting time was very high. There are kits available in the, some companies are making kits which are not the engine manufacturer to change. What's your opinion about those kits? Is it worth considering those options?
I now understand we have Bertil here also. Yeah, actually I would say this is Bertil, maybe the 4-stroke engine manufacturers that know most about that part, because already in 2015 you converted the Stena project and to methanol, and I would say we are still in a learning phase to a certain extent, and go for their experience. We are talking about vessels, its availability, reliability, and especially also safety. So go with them first, find out the opportunities, find out the business case also. That's, and I have to say, yes, difficult to find, but I see all OEMs being interested in finding design now. Things are really moving. So it's like you have to be, and I don't know if you agree, you have to be also in the segment of methanol and cover as much as you can in your engine program. Of course there is priorities and you cannot do it all in once. It takes time, but I'm sure it will come. So keep with the OEMs, and there are opportunities. I was speaking about 4-stroke engine. In some cases I assume it could actually be a better solution to take it out and take another one in, depending on what you make, of course, and also you can say what time was it developed. You can say the engine itself, is it worthwhile to converting? It's a little bit more difficult with the 2-stroke engine, where you have built the ship around the engine itself. It's not that easy just to exchange that. And coming a little bit back to opportunities, as I mentioned, the mechanical engines with camshaft and so on, they are going to have a long process if they are converted, because you have first of all to change the camshaft to hydraulic injection and opening of exhaust valve. Then you have the regulations that have to be electronic, and it's like the next step will then be you also need to do it to a dual fuel engine. And what I see today for the OEM is to say, okay, we take the new engine electronically controlled or whatever they have as, you can say, a new engine, to take care of them first, and then later on, if there is a market, I'm sure that you will also look into that. And there might be a market at a certain time. We're thinking about these 25 years of living time for a vessel. So it might be necessary to reach that in the transition.
Just want to add on to your question for my own understanding. See, the conversion of a dual fuel engine or the full driven by the methanol is something different perspective. But what about for the existing engines, the fuel of currently used, maybe 10%, 15%? What is its prospects?
When I was in METHANOL many times, it's actually not tested on 2-stroke engine. And there is another thing we have to remember. All the engines have to be in compliance with an X2, an X6, Tier 2. And that means also, when you start mixing things, the authorities, IMEI, they will have you to test this mixing for Tier 2. So that's problematic in that sense.
Regarding the regulatory compliance, I'm talking about the technical feasibility and the supervision.
I do research should be done. Irritating. For me as a technician, it's irritating, and a regulation will stop the progress for seeing what happens. We know from the biofuel, we know the ship owner has for many years tested and put biofuel into the normal fuel oil, and thereby having maybe 10-20% reduction in CO2. That could be in principle the same. It could also be that you need some kind of additives for stability reasons and so on. We know the ethanol is playing. So, yeah, yeah, I would say I have investigated also, and I haven't found anything yet. It's not tested enough, to be quite honest. The priorities have been different.
Basically, when we look at a vessel for a retrofit conversion, it is the feasibility which comes first, because we don't have to really see the engine only as a standalone unit for conversion. We have to look also around that. Where is the space for the fuel gas supply systems? What could be the additional safety factors has to be built in? So all those factors, the feasibility has to go. So you talked about the kits. So it's more like certain type of engines where the conversion possibilities are there, and that's how we are talking to the Shipping Corporation of India on Wärtsilä 32 engines. But presently it's not available across all the engine types. It is being developed. The solutions are being developed, but a holistic approach has to be followed. Like the feasibility study comes first, and which takes about 3 months of time, to look. For the conversion. Thank you. On the methanol, I have to still check internally, and then I will come back to you. That's fine. Thanks.
We have to make any questions, any further questions? Okay, the last one.
Methanol have energy content is very low, other than other fuels. For the ships and all, now the SFOC will be more for the fuel. So how the storage infrastructure and everything is, this challenge can be addressed.
Hello. Yep. Yeah, you could say the easiest of the different fuels when it comes to tanks is also methanol, because there's no pressure, it is not irrigating, and so forth. You can actually have different shapes. You can use steel, coated steel. You have to be coated steel. This is what every runner they use on their vessels. But it is correct, you have a size which is maybe twice of normal fuel oil. On the other hand, you don't have to have it like a pressure tank, round and things like that. You can have it in different shapes. There is still a big discussion about is it needed with a cofferdam. There is new design from the Baltic countries. They have a new design of, you can say, in between instead of cofferdam. Would be more optimal. Generally, I see a little bit of a problem with the standardization, because it's like when you make a standard safety-wise, you take the worst one and then use that. Because LNG was the first one, but there's a lot of aspects with methanol which is not investigated enough, and actually could be more practical, more easy, and also to operate for the operator. Also, when it comes to, let's take one example, it's about the exchange of air in the engine room and so on, which is actually based on the LNG, but could be much lower for methanol. And there you continuously have, for the fan, it's quite big fan, you have continuously a consumption. So it's a very good question, and of course some of the vessel types, they have an issue there. You also see when it comes to other vessels that have to exchange, and you put in a new fuel, you need to have the capacity or the space for putting in new tanks and so on. Sometimes they can do it on deck, depending on the application. Sometimes it's over the, you can say, what's it called? Yeah, the steering house and things like that, depending on where you have the bridge. So there's many configurations, but a lot of things are done on that side. And if you have questions to that after this, just come and I can tell you what we have seen.
invite Mehra sir to give momentum to CS sir.
I think before going for that, I will just give the answer to Francis from our understanding. See, whatever the assessment as of now, he was talking about the new engine will be around 10% more than the calculations. But our understanding with the availability of the current scenario, cost for any kind of true green engine would be something around the 40 to 50% and the conventional fossil fuel engines. And the next is cost of operation. Cost of operation in the most promising scenario, it will be almost 70%. If it is more than double, it will be the cost of operation. That is the pump assessment as of now.
Can I request Mohan Pal sir to please hand over the moment to Alexander Toll, please. Can I request him to please hand it over to Mr. K. And can you please come on stage? The most important person of IMEI. If Neeta and Yogesh would not be there, it would be very difficult for us to operate. Please, can you hand over to Prakriti Sethi, please?
Good afternoon, everyone. It's my privilege to deliver a vote of thanks at this meaningful session on behalf of IMEI Mumbai branch. First, our heartfelt thanks to Shri Ajithkumar Sukumaran, Chief Surveyor, DG Shipping, for gracing this occasion as a chief guest and for his visionary address that reinforced our industry's evolving regulatory landscape. We extend our gratitude to METHANOL Institute, especially Mr. Alexander Doll, Ms. Prakriti Sethi, Kejit Abo for their insightful presentations. On methanol potential as a low-carbon marine fuel, key regulatory frameworks, case studies from leading adopters like Maersk, which had launched methanol fuel vessels and is leading the decarbonization pathway. Special thanks to our honorary chairman, Mr. David Dibbarkar, who despite being not available here had sent a message of welcoming everyone. A special thanks to Mr. Mehra, who was the heart of all whatever we did and all our activities in IMEI. I would say Mr. Mehra is synonymous to IMEI Mumbai. Really grateful for the effort he has been putting in, not only in this event, so many different events. I would also like to thank Shri Mohan Pal Singh for arranging this venue, making sure everything is working and also giving us safety briefing. I would also like to thank Neeta for behind the scenes working on this, organizing this event. A lot of effort has gone from her side in coordinating with different stakeholders. Finally, I would like to thank all of you for coming to this occasion and gracing this occasion. It would not have been a successful event without presence of such a responsive and good audience. As it was discussed that methanol may not be the only solution. There is a gamut of alternate fuels available, biofuel is there, ammonia is there, hydrogen is there. So as a part of our exploration, I would say we would also have in this series of events exploring other fuels options as well. I think this went well, and I think we should continue doing more on different kind of fuels and discussions on pros and cons. I don't think we have a perfect solution, but we are on our pathway to in the right direction. Thank you everyone once again.
So that with the Chief Surveyor of India, please come forward. Please come forward. Come forward. Come, take the chance, take the opportunity. Gopi Krishna sir also. So when you go for orals, you know, when you see him, you know, okay, this is the person I met him.